5.2 Part B is still talking about exponents when they are 0 or negative, but as you can see from the examples below, we're going to start to see algebra, letters, in the problems that we're working. So we're just going to put a quick reminder up here at the top of the page of what our rules are for these so that it's there for our reference. So recall that if a is not equal to 0, then a to the 0 is equal to 1. And our negative exponent rules were that a to the negative 1 is equal to 1 over a to the positive n. I think I just said negative 1. I meant negative n. A to the negative n is equal to 1 over a to the positive n. And if you've got one that already has a numerator and denominator, a over b to the negative n is going to be equal to b over a to the positive n. So let's try some examples. In our examples, they tell us to assume that the variable is not equal to 0. So all of these are going to meet this case requirement of a not being equal to 0. So if we look at k to the 0 power, just like 3 to the 0 power was equal to 1, k to the 0 power is also equal to 1. Negative m, since the negative is getting raised to the power also, is going to be equal to 1. Here, only the q gets raised to the 0 power. So we end up with negative 3 times 1, which is negative 3. And now to look at some examples with our negative exponents. Y to the negative 4 is the same as 1 over y to the 4th. And 3 over d to the negative 4, we're going to have our fraction numerator and denominator change places. When that happens, they've moved, so they've used their pass on the elevator, so that negative goes away. Now we're going to raise it to the 4th power. So we have d to the 4th here, and 81 at the bottom. 7f to the negative 7 looks a little trickier because this is not in parentheses. So the negative 7 is applying only to the f. So only the f gets to ride the elevator down. The 7 stays where it is. The f goes to the bottom and gets raised to the 7th power. In number 38, both of our variables are going to get to take a ride on the elevator. The f is going to go down into the denominator, and since f to the 1 is the same thing as f, we'll just leave its exponent off. The g is going to ride the elevator up and become g to the 5th. Put a little bigger tail on that so you can tell it's a g. So what about this one? Again, recall, just like with 37, that the negative 10 applies only to the s. So only the s is riding the elevator down. The t to the 4 doesn't have a negative, so it doesn't have a pass, so it's going to stay where it is and be joined by the s to the 10. So my marker's getting a little fat here. That says 9 over t to the 4 s to the 10. In this next example, c to the negative 2, d to the negative 7, both of these variables have elevator passes with those negatives. So we're going to end up with a 1 on the top and a c squared d to the 7 on the bottom. In this next one, remember that rule about being able to simplify things inside fractions before you start applying their exponents? So let's do that first, parentheses first. Make this 4 into a 2, the 2 into a 1. So now we're taking s to the 4t over 2f squared, and that's what's getting raised to the negative 2. So we'll have those two switch places using their negative. This is going to become 2f squared over s to the 4t. Elevator pass used, so it's now just squared. And in this last little bit of room, squeeze in the answer. 2 when we square it is a 4. 2 times 2 is 4. So we have 4f to the 4th on the top. And applying the 2 to each piece in my denominator, the 2, I'm sorry, that was an s. S to the 4th is going to become s to the 8, and the t gets just the 2, so it becomes t squared. And our final example, we're going to use that negative elevator pass to have these two numbers switch places. The 6, since it's outside, gets left alone. So this becomes 6 times r over 1 squared. And since we don't need to keep that denominator around, we're just going to write it as 6r squared.